Alright, math fans, our topic for today is talking about congruent figures, and we're going to learn something called CPCTC. It's an acronym, and I'll tell you what it means in a minute. But first of all, let me give you your math joke for the day. What is the Tyrannosaurus Rex's favorite number, or what was Tyrannosaurus Rex's favorite number? And the answer is 8. Okay, so let's talk about congruence. And we're going to say congruent triangles and polygons. The idea of congruence, and the symbol for that, is the equal sign with the little wave right above it. Congruence means the same size and the same shape. Okay, so when you talk about congruent figures, you're saying they have the same size, they have the same shape. Now the size is the length of sides. The shape is the angle measure. So in terms of geometry, when you say size, when you say shape, size is talking about length and distance, shape is talking about angles. Now specifically, congruent triangles mean that all the pairs of corresponding parts are congruent. Okay, and we'll explain what that is in terms of a picture. We'll do that in a second here. All pairs of corresponding parts are congruent. Notice that I have an arrow where a double arrow that's going in both directions. That is what we call a biconditional. And we talked about this with converse, inverse, contrapositive. Biconditional. What it means is that it works both ways. So if we said two triangles are congruent, then we can say all the pairs of corresponding parts are congruent. Okay, so we can go from left to right. But we could also switch this. We could go from right to left, which is called the converse. If all pairs of corresponding parts are congruent, then the triangles also have to be congruent. That's a biconditional. Now, this is kind of a lot to say, so the way that we abbreviate it is we call it CPCTC. Corresponding parts of congruent triangles are congruent. CPCTC. Okay, so here's what it looks like. If we look at example number 1, write 6 congruent statements if triangle ABC is congruent to triangle DEF. Now this is really important, the order of the letters. ABC, triangle ABC is congruent to triangle DEF. One thing before we start labeling this picture here to remember, the idea of corresponding. Okay, when you see that word corresponding, what that means is you're looking at two things that are the same position. Two things that are in the same position. It could be a point, it could be angles, it could be sides. They're in the same position, just in a different place in the picture. But they're in the same position compared to everything else. So write 6 congruent statements. The way that they say this triangle ABC is congruent to triangle DEF, well, that tells you that A corresponds to D. They're the first letter in both of these. Okay, so A goes to D, B corresponds to E, and then C corresponds to F. So in the picture, angle A corresponds to angle D. Those are congruent. They say the triangles are congruent, so that means all these parts are congruent. Angle B would match up with the second letter here, which is angle E, and then the third letter C, angle C, would correspond to third letter angle F, and those would be congruent. Now notice that I used 1 arc here, 2 arcs here, 3 arcs here. These corresponding angles are congruent, but not all the angles are congruent. Okay, so what we can say is 6 congruent statements. Number 1, we can say angle A is congruent to angle D. Number 2, we can say that angle B is congruent to angle E. And number 3, we can say that angle C is congruent to angle F. Now that's 3 statements, and those are for the angles. Well, what else is congruent? We also have sides. When you look at a triangle, you have 3 angles, you have 3 sides. segment AB. Now AB is the first two letters. The first two letters here is DE. Those correspond, they are congruent. Now I label sides with these little tally marks. Angles you label with arcs, but this, sides, we label with these marks. Now let's see, BC, that segment is congruent to EF. BC matches up to EF. So it's 2 marks and 2 marks, and then that means that AC has to correspond to DF. So the fourth statement we can write, we can say segment AB. Now I'm going to put a segment bar there. Segment AB, that side, is congruent to segment DE. Number 5, we could say that BC, segment BC is congruent to segment EF. And then the last thing we can say is that segment AC is congruent to segment DF. Those are 6 congruence statements based on this. If they tell you the two triangles are congruent, then that means all the corresponding parts have to be congruent. That's CPCTC. If you say it fast, CPCTC. Alright, now number 2, write 6 congruent statements if the two triangles are congruent. So they're telling us that the top triangle is congruent to the bottom triangle. Now the way that you match this up, you have to be very careful. If I look at what they've already given me, we have 2 sets of corresponding sides that are congruent. Notice that both triangles have the same third side. They both have ZY. This is what I call a common side. And we'll talk about this more in the next few days. A common side. Now the way I'm going to mark that, I'm going to put an X right there. That gets shared between both of these figures. Okay, now with the angles, angle X, that is between the 1 mark side and the 2 mark side. So in the bottom triangle, the 1 mark side and the 2 mark side, that's angle H, those correspond. Now angle XZY, angle XZY, and this is where you have to be careful. That's between the 1 mark and the common side in the top triangle. In the bottom triangle, here's the 1 mark, here's the common side. That means this is your corresponding angle. And then that means that these, this one here and this one here, correspond. Alright, so write 6 congruent statements. Number 1, we can say angle X is congruent to angle H. Notice that I only use 1 letter when I match those up. Angle X is congruent to angle H. And that's good, right there. Now number 2, I could say angle XZY. Angle XZY, that has 2 arcs. Now I can't say just angle Z, because there's a lot of angle Z's. There's the big one, and there's the 2 small ones. So that's why I'm using XZY. I'm using 3 letters. Is congruent to angle, we say HYZ. That's this angle here, HYZ. Angle HYZ. And then number 3, angle XYZ is congruent to angle HZY. So those are the 3 sets of corresponding angles that are congruent. Okay, now for the sides, we have segment XZ is congruent to segment HY. We have segment XY is congruent to segment HZ, 2 marks and 2 marks. So segment XY is congruent to segment HZ. And then the last one here, you could say that ZY, and you could say ZY is congruent to YZ. Alright, those mean the same thing right there. If you say ZY is congruent to ZY, that's fine as well. Okay, and that's the end of that problem. We wrote the 6 congruent statements. One thing that we could also add in, though, is what we call the triangle congruence. The triangle congruence statement would be to say that triangle XYZ is congruent to triangle, now let's see, X to Y to Z is 1 mark, 3 marks, 2 marks. So this would be 1 mark is H, 3 is Z, 2 is Y. So triangle HZY. Use your labeling. Always label your picture. It makes it so much easier to match up what you're doing. All right, and then the bottom here, so congruent triangles means the corresponding parts of congruent triangles are congruent, CPCTC. Congruent polygons, it doesn't have to be triangles, it could be parallelograms, it could be pentagons. What that means is that all the pairs of corresponding parts are congruent. So that's the end of the front of the notes, that's the end of part 1. Go ahead and flip it over and we'll get to part 2.